viewers, and welcome to another video. Today we are going to talk about SeaweedFS. I'm excited to tell you that I partnered up with Code Combat to bring your kid a learning opportunity. Back in my day, there were no one that could tutor me. I knew more than the teachers, and I had to put in the work because there were no other option. Unlock your child's coding potential with Code Combat's live online classes. The classes are led by experts who make learning an exciting and rewarding experience. With their help, your child will work through coding challenges and feel proud of their accomplishments. Personal attention and a structured curriculum will help your child become a confident coder. I always said that I hope that you learned something today, and now your kid can. Follow the link in the description and enter the promo code EXPLORER10 at checkout for a 10% discount, and all subscriptions have a 30-day money-back guarantee. And we are going to compare it with Ceph. We're going to talk about the installation. We're going to talk about the different services and so on. And Seaweed is very similar to Ceph, but it has some limitations and it's a little bit on the developer side. So it's more a tool that you set up and use if you're more comfortable with handling a complex setup than if you just want a good solution for your problem. So let's look at some performance numbers here. We will switch over to my screen. So here we have Seaweed performance, comparing Seaweed against Ceph in all the use cases that are available. And what I mean with that is that we can compare different replication patterns, but we can't really compare on erasure coding because that is actually something that I didn't really figure out. It seemed to be very programmatically, and I will talk a bit more about it later. But we will compare at least the performance against different copies of data. So if we look into the performance here, we first off want to give this disclaimer again. Everything is running on the same machine. It was lightly used. I watched some videos or something like that. No network latency because it's the same machine, same hard drive, but it's virtualized in 4 different machines. Those machines in turn have minimal memory, 2 megabytes, and minimal CPU, only 1 CPU per instance. And when it comes to these single MDS and Rados gateway, it's the same thing as we had for Ceph, but in this case, you call it a filer. So a single filer instance. So that is what we are using at the moment. So these are the performance metrics. Here we have sequential read, and we have both single-threaded and multi-threaded. So when it comes to multi-threaded read, we have actually one replica as SeaweedFS is much faster, and also normal is faster than Ceph Quincy. When it comes to the sequential read one thread, it's much faster when it comes to that. The difference is quite enormous. And when it comes to write, when it comes to one replica of SeaweedFS, it's much faster, but with 3 replicas, it's even a little slower than Quincy. And when it comes to single-threaded, it's faster in both cases when it comes to sequential write. But when we look at the random numbers, we have a totally different picture. So here we have random and small, of course. So these are small objects, only 4K in size. And then we can see that Quincy is really fast at random reads, probably because we have 3 different machines that we can read from. And here it seems to be much slower. When it comes to sequential read, it's pretty much the same values. And when it comes to write, Seaweed is faster again, even with a small object. And when I looked at the documentation for Seaweed, they had that as a point that they said that we are really fast at writing things, and the normal setup of SeaweedFS is actually 1 replica. But the normal for Ceph is 3 replicas, and you should have replicated over more than 1 replica in order to get some kind of redundancy in your data. If we continue, so this was the K disk mark when we were using it as a file system, but they also have support for S3. So with ROP, we will test the S3 performance, and here we can see that SeaweedFS and Quincy is pretty much similar when it comes to the normal setup with 3 replicas, but Seaweed is a little bit faster when it comes to 1 replica. Same goes for sequential read, 1 megabytes, 1 thread. There we see that Quincy is a little bit faster in the normal case, sequential read. And the same goes for sequential write. The numbers here are pretty similar to when we looked at the numbers for the file system. And last but not least, random write. We see here that Seaweed is faster on the random writes against Quincy, and also a lot faster when it comes to random writes, as we suspected. So that gives us a pretty good case for using Seaweed then. It's a lot faster than Ceph. But if we switch over to the admin case here, so this is the admin console for SeaweedFS. You have this master service that I'm currently running, and each service that you have started has their own web GUI. So you can look at any service and their web GUI, and you will get some stats. And here we can see the volume size limit, how much is free. We can see how many volumes and current connections we have here. And here down here we see the topology, and we see that we have 4 different machines that have hard drives or volumes connected. We are using the default data center and the default rack. So you could have a Seaweed that is on multiple data centers and multiple racks and have replicated copies over the different instances. So that is a good feature available in Ceph as well. Ceph has it even more granular, but I think this is good enough. And then we see how many volumes we have per instance here, and what volumes IDs those have. And we also see the erasing a coding charge, and I don't have any erasing here. And we see that we can have max of 8. And if we look into the specific machine here, we can see the volumes available. We can see how large the volumes are, how many files they have, and so on. So we can see a lot of information here. We can see how much are free on this machine, and also some statistics over the reading here. And we can also look at the filer, and here we see the file system. So here we can actually create new folders and upload things directly to the filer instance, and it will be spread over the different machines. Where in the buckets here we can see the test bucket, and here we have the test that we ran earlier. So everything will be stored in the same kind of filer instance, filer system, and when buckets as S3 is just another implementation of that. So this is much less functionality and less control and less statistics than Ceph has, but it's leaner and faster. So the story is pretty much similar to before. So how do we set this up then? If we go to my machine here, first off, you need to download Go. So you will vget that down to your machine, and it's not that big. You need to have 1.20 at least, and that is pretty much the latest version, so you need to pretty much have that. And then you will use this little script here in order to remove the old Go installation, sudo tar up the new installation to that directory, and I give it some password here. So there it has copied that over. Then we need to export the path, and we need to export both the local Go bin directory and our own home bin directory, because we want all the installed files that we have also available in our path. I actually added it to my profile, so whenever I restart the server or run source on my profile, I will get that exported path. And then we can run this installation script here go install GitHub, SeaweedFS, SeaweedFS, Weed latest. And when we run that, we will get the latest version of Weed downloaded and installed on our system. SeaweedFS has been in the works for almost 10 years. So they have a pretty good developer story, and there is a bunch of commits, a bunch of people working on the project and so on. So it's not really just something that was created yesterday. So there is a bunch of functionality here. But when you have installed that, you should have the weed command here. And here we have a bunch of different things that we can run. First off, you can scaffold a configuration file. Very important. You can run this as a server. Then it will be both a master, a volume, and a filer in one instance. I would say that I would like to split it up in multiple instances, but you can run it as just one instance. And you can run a filer as an S3. You can run a master server, you can run a filer server, and you can run a volume server. So what I set up is a bunch of different services. So first off, on my C1, I have run this command here. So the weed master, you can do like that. So we have it at the top. So the weed master with the IP of C1, port 933, and the directory for my data is /data, and my peers are C1, C2, and C3, and the different IPs for that. And I also have another command here that also is very important, that you can set a default replication. You could change the replication afterwards, but it seems like if I do change it and then do some maintenance and try to fix the replication, it will run through it, but as soon as I save any new data, the default replication will fall in and it will create a bunch of new versions of it, which is not really good. So to keep the default replication, you need to set it when you start the service. And what does these numbers stand for then? 0, 0, 2. This means that I want on my data center to have a 0, on my rack to have a 0, and on the specific host I want to have a 2. And 0, 1, 2 are the available values. So here I say that I want to have one copy that is saved on one instance, and then I want to have 2 extra copies of that data on 2 different instances. So a 2 says that you want 2 more copies of your data. So if you had 0, 0, 0, which is default, you would just have 1 copy of your data. But you could of course say that I want to have 2, 0, 0. So for each data center I set up, I want to have 2 separate copies on other data centers. So that is the setup for that one. And then in order to set up a volume server, I have an extra drive in this machine here, dev SDB, but it's currently mapped to my vol drive here on my machine. So what I've done is run makeFS on that. So I make an exe4 on that drive. Then I created that directory with make vol, and then after that I mounted it to that directory, that volume directory, and I also changed the owner to my user on this system to that vol directory. So this volume directory that we have here contains the different parts of this system. So here we have the saved volumes on this system. So if we go back to this setup here and look at number 4, we can see that we have 7, 8, and 13 saved here as volumes. And if we go back here, we see 7, 13, and 8. So that is the actual data saved on this volume as files. We also have a filer instance here where we can see the different volumes available and where it stores the different files in different folders. That is more the metadata stored in that directory. We can also go into C1 and see in the data here we have the data for the actual master host that has the configuration and so on. And then last but not least, to set up a volume, we run this command here. So we will run weed volume and then the directory where we will have our data. I would have liked if you could say I want to use this specific drive instead, and that it could handle its own file system as Ceph does, but now it's only working in the file system, the normal file system. And then you set a port where you can reach this volume, and then the master servers it should talk to. So that is the setup for a volume. And then we have the filer instance. So if we just want the filer instance that has a file server, then we can set it up and say that that file server should have port 888. So that was what we looked at earlier. And then what the master server should be that you can find this filer from. But if we want to run an S3, we need to run this command. So here we have the same we set up. So we have a file system that we could use. And then we say we want to run S3 on the port 9000 with this configuration over here. So we have a configuration file on C4 for the S3 configuration. So in this configuration, we say what the access keys should be. And these are the access keys that I have been using for testing. So those are the same as we did for Ceph. And then we also need to say what kind of actions you can do in your S3 bucket. So I can read, write, list, tagging, and admin tasks. So that are all the options that you have in order to set up your system. I have set it up in this case with screen. So if we go in here and look at one of the screen instance, so we can take the last one here, 8542. So this should be the filer instance that is running at the moment. So I use screen because I don't think there is a really good story on how to set this up for production use yet. You could use it with Docker images and add that extra complexity to it. But as a system service, it hasn't really been touted as a good option yet. But you could, of course, set up systemd to start and stop these services. But as a test, I didn't do that. We have more features. We can mount this drive, of course. So here I can run this weed command and then mount. And then I say which filer server I should connect to, the directory on my local host that I want to mount to, and what the filer path should be. So if I run this, and supply a password here. Then I could actually go into the Seaweed directory, and here I can see those files, and I can also see buckets here. So you could actually remove things in your S3 buckets from your file system. Maybe not a good use case, but you could. And then we have this shell command here. So I can say weed shell filer and the filer server and then the master servers. So if we go in here in the shell, I can do an ls and see the actual files in my filer instance. But if we run help here, we see that we have a bunch more commands that we can do. And what I looked into was these volume commands where you could change the volume balance, you can balance the volumes, you could configure replication. You also up here had some command for easy encode data. I tried that as well. But it seems like when you do an easy encode for a specific one, it does it just temporarily. And I tried to decode a volume and actually got stuck in a state where I couldn't actually decode the erasure encoded volumes or the erasure encoded values. which is never good, that you can lose data because there is a configuration issue or encode decode issue. So one part that I found when I looked into the documentation was that you could set up a configuration file with a script that was running every 2 minutes or so in order to erasure encode the data that came in. So you stored it as one copy normally, and then you erasure encoded it, and then it will store with more copies and will store with in a way that is more is more resilient. The problematic part here is both that it's not instant, so you need to run it from time to time in order to get the data into that state, and the read functionality after that is not any problem, but during the actual encoding the file system will be locked, so you will lose contact with it. Not a good solution either. And moreover, the erasure encoding that is supported, that I found in a code, is currently 10 copies, and 4 of those copies are checksums. That's the only setup you have. I didn't see anywhere that you could change that setup. I went through a bunch of documentation, couldn't really read that there were any other setup available, which is a little bit of a sad point, that you could have 14 hosts and 4 of them are CRC and then the other 10 are data, and that is the option you have. It's a good option, but you should be able to set your own erasure encoding schema. So I feel that this system is not really something that I would run in production. It is something that you could use as a tool for your own storage at home, or if you have something that you want to either have a larger data drive that you want to have over multiple systems, then you can run it in one copy mode, or if you want a little bit more redundancy, you can run it in 2 copy mode, or even turn on erasure encoding if you are programmatically inclined and want to write those kind of scripts in order to make it into an erasure encoding way. But keep in mind, if you erasure encode, you might not be able to go back. I tried to do it, and 2 of my volumes got stuck in a state where they were not able to be decoded again after I had encoded them. We have talked about SeaweedFS and its performance benefit over Ceph, but we also talked about the lack of functionalities in the system and it being more tailored for an approach which is more towards developers or system integrators, could be used in some cases for systems as just an extra file system where the actual client doesn't care about what they are running. They just want a system to store a lot of data and in a way that they can grow over time. Because I can see a case where you have this running with 5 volumes, for instance, and then you just add a 6th volume and you have more data available to the client, and they don't really have to care about how it actually works under the hood. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you liked this video. Give it a like, share it with your friends and colleagues. If you have any comments or suggestions, leave them down in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.